Here we have price or dollars, and here we have quantity, and this is the demand curve. This number is 100, this number is 50, and we're trying to choose a point. And of course, now there's also cost curves involved. So the first thing I'm going to do is I'm going to draw what we call the marginal cost curve here. So I want you to take literally 30 seconds to remind yourself what marginal cost means, and then look at this total cost curve and tell me what you think marginal cost is. First, ask yourself, what is marginal cost again? What is marginal anything in the world? Oh, okay, that's what it means. Now let me look at the total cost curve and figure out what marginal cost is in this particular scenario. All right. Use the chat window and write down what you think the marginal cost in this scenario is. All right, majority rules today. Majority is correct. It is 4. That's correct. So how did you figure that out? Well, it was hopefully straightforward. Maybe took a few minutes, a little bit of thinking. Well, marginal cost is the change in cost, additional cost, when you produce one additional unit. So if you look at the total cost curve, every time you increase Q by 1, total cost goes up by 4. So when Q is 1, TC is 14. When Q is 2, TC is 18, so it went up by 4. It's 3, it's 22, it went up by another 4. It just keeps going up by 4. Additional quantity, $4. So I'm going to go ahead and draw that here. So this is my marginal cost. And it's flat, same, it's always 4. Could be upward sloping, doesn't matter. But in this particular problem, it's flat. This problem would become superbly simple to solve if we could draw the marginal benefit for the monopolist. You guys agree? Marginal cost benefit analysis would be kind of nice if we could apply it here, and then it'd be done. So we already have the marginal cost. If we could have the marginal benefit, we'd be done. Now, what is a marginal benefit for a monopolist? Every time the monopolist produces one extra unit, what is the extra benefit for them? Well, you should recognize that the extra benefit is marginal revenue, the extra revenue that they bring in. So remember, they are trying to maximize profit. They're trying to maximize profit. And profit is total revenue minus total cost. Total revenue is nothing but P times Q. So the story is, every time you produce one extra unit, there is an extra cost, marginal cost, and there's some extra revenue, marginal revenue. So if marginal revenue is the marginal benefit here. So if marginal revenue is higher than marginal cost, you should produce more. If marginal revenue is lower than marginal cost, you should stop. So the usual marginal cost benefit analysis. So what we are going to now do is spend the next 10 minutes really focusing on marginal revenue. So this, we know what total revenue is, P multiplied by Q, we get that. But what we're going to do is we're going to spend a lot of time on what marginal revenue is. And for monopolists, it's a little bit interesting. It's not the same as you would, it's not as straightforward as you'd imagine it to be. Is everybody clear as to where we are headed right now? So we are trying to solve a monopoly problem. We've broken it down into a marginal cost aspect and a marginal benefit aspect. And I have said that the marginal benefit is nothing but marginal revenue. Every time I sell one extra unit, what is the extra amount of money I bring in? And so I'm trying to solve for what the marginal revenue will look like. Once I can solve that, it'll be straightforward, easy peasy MBMC analysis. Okay. Look, I'm going to give you a made up example for now, not associated with this demand curve, to make a point. Imagine the firm is thinking of different quantities to sell, and the price is related to that, as you imagine. So when they try to sell 10 quantity, the price is 7. The price that they can charge is 7. When they're trying to sell 11 quantities, the price that they can charge is $6. When they try to sell 12 quantities, every time they try to sell more quantities, they end up charging a lower price. They don't have an option. They're a monopoly, single price monopoly. This one is say 5. I made these numbers up. These are not connected to the demand curve. Usually they will come from the demand curve. They don't come out of thin air. They usually come from the demand curve. I'm choosing smaller numbers. It's going to make our life easy. Okay. And then the last one, 4, and you could go on and on. So let's think about in this table, how would you solve for marginal revenue? So I would add another thing called total revenue here. And hopefully you know what the total revenues are. It's $70, $66. What is this? $60, 52. So far, so good. I need lots of head bobs or just plain good old-fashioned questions, hand raising or whatnot. Okay. And then you should be able to figure out marginal revenue, which is what we're after. How did the revenue change when we went from 10 to 11? Well, this change is basically -4. This changes -6. This changes -8. Total revenue actually fell. The more you tried to sell, total revenue fell. Okay. So let's see what's going on. So you can just do it in a table form. This is what it looks like. Now let's think about a very particular story. Imagine you could sell 10 units or you could sell 11 units. If you sell 10 units, you can charge $10. If you sell 11 units, you can charge $9. So let's kind of see the logic of what's going on. So if you go with 10 units, you can charge $10, $10. Oh, I'm going to drone on about this $10, $10, 5 of those, another $10, another $10, another $10, $10, $10. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you would make $100. Now, the interesting thing about monopolists is they have to charge the exact same price to everybody. So if they try to sell 1 extra unit, if they want to sell 11 units, they're selling 1 extra unit, so they're bringing in a little bit more money, but they're reducing the price on every unit that they're selling. So they were kind of saying, okay, what are we gonna? We're sitting here like we are the board of the monopoly, and we are like, hey, what price are we gonna set? Are we gonna set price 10 or are we gonna set price 9? And you say something like, oh yeah, we are gonna set price 10. Okay, if we set price 10, we sell 10 units. But if we set price 9, we sell price, we sell 11 units. So how many units do you want to sell? I want to sell 11 units. Well, hold your horses. Let's see how that's going to work. If you want to sell 11 units, you cannot charge $10 anymore. You have to charge $9. So what's going to happen is, if you try to sell 11 units, you're not going to make $10. You're going to make $9. 9. I'm going to stop writing the dollar sign. 3, 4, 5, 6. 7, 8, 9, 10, 11. So basically, you are selling 1 extra unit. So you had already sold these units before. If you would have tried to sell 10 units, you would have sold those. But you have now 1 additional unit you're selling. So the extra revenue that you're bringing in is plus $9 because you're selling 1 extra unit. But you're also losing $1 here, $1 here, $1 here, $1 here, $1 here. So you're also losing $10. So at the end of the day, your marginal revenue is actually -1. You lost money by trying to sell more. So marginal revenue in a perfectly competitive market and a monopoly is very different. In a perfectly competitive market, you're a price taker. I want to sell soda. How much is the price? Going price is $5. I want to sell 1 extra unit. Can I sell it? Yes, you can. $5. Marginal revenue is $5. I want to sell another extra one. Oh, little firm, you are so little in this perfectly competitive world. You selling one extra soda is not going to change the price. You may sell that for $5. Are you telling me I can sell another one for $5? Yes, you may. Go sell it for $5. So every time they produce one extra unit in a perfectly competitive market, marginal revenue is just the price. $5, $5, $5, $5. Monopoly, not the same. Monopoly, every time they try to sell, if they want to sell more, they will have to reduce the price on every single unit. And so the marginal revenue calculation is slightly different. It's not the same. You will be selling that extra unit, and that is going to bring you some extra money. But because you are selling more, you are losing money on every other unit. And you will have to take both into account. Is the intuition clear as to what's going on under the surface? Okay, so you kind of knew that, but I wanted to really break it down and show it to you, like where this, there's this tension. It's not about just, I sold one extra, so I got $5 more. No. In trying to sell that extra one, not only did you get $5, but you reduced the price on every other unit you sold. So you actually lost some money too. So you have to take that into account. That's your change in. You put those two together, that's your change in marginal revenue. So going back to our original problem, this is the original problem. I'm going to rewrite it now. What are the numbers I chose? 2Q. Okay. So we said the demand curve was P equals 100 minus 2Q. And we say the total cost curve was, our total cost was 10 plus 4Q. Is that right? Yeah. Okay. So let's redo this problem. So you have price here, you have quantity here, and you have your demand curve, 150. Nothing changed. I'm just redrawing what we had before. Okay. So when you start to increase your quantities, you are selling the first one, say, for $100. The second one you're selling for, say, $99, $98, $97. You're kind of charging a lower and lower price, but your marginal revenue will not be at, so say this number is, I'm just going to make it up. Imagine this number is 98, 97. Your marginal revenue will not be 97. Your marginal revenue will be less than 97. Because that extra unit you're selling for 97, but you had to reduce the price on all of the other earlier units. So marginal revenue will be somewhere lower than this number. It will not be 97. I don't know what number it will be. It will be less than 97. Marginal revenue will not be here. It will be less than that. Marginal revenue will not be here. It will be less than that. It will be always underneath. It will never be where the demand curve is. Because the demand curve tells you what price you're selling the next unit at, what price you're selling the next unit at. And marginal revenue is telling you the change in P multiplied by Q, which we just saw will be lower than the price. So, hey, I sold the next unit for $7. I bet your marginal revenue is less than $7, Mr. Monopolist, Miss Monopolist, because you had to probably reduce all of your prices. So marginal revenue is always under the demand curve. So that's one piece. The second piece is when you sell the very first unit, the very, very, very first unit, there is no loss of money or anything. There's no, this part, this negative thing doesn't apply to you anymore when you're selling the very first unit. So in that sense, your marginal revenue is exactly 100 for the very first unit that you sell. Okay, so if you charge, $110, you sell $0. If you charge $105, your sale is $0. If you charge $101, your sale is $0. The very moment you charge 100 or slightly more than 100, you sell one unit. So basically, that is the full marginal revenue. So marginal revenue actually starts here, and then marginal revenue stays under. There is an actual formula for the marginal revenue, and the marginal revenue formula looks like this. It is a straight line that has twice the slope of the demand curve, but the same intersection. So let me I didn't give you any logic as to where that came from. I just laid it on you. I just told you this is it. I'm asserting. So let me repeat what I said. If I gave you a demand curve like this, just make something up, 40, 30, made it up. This is your demand curve. I know my marginal revenue curve will start here at the same intersection, will have twice the slope as the demand curve and be a straight line. And it will hit zero exactly at halfway. That's what I'm telling you. I'm asserting that to you. I've not told you where it came from, but I'm asserting that to you. This will be your marginal revenue. If I said, well, what if this was different? What if I had 142 here and 366 here? What will my marginal revenue look like? Well, it'll look again. It always starts here, because the very time you sell the first unit, that's the amount of money you bring in. There's no extra loss of reducing prices. And it always hits zero. Marginal revenue always hits zero when you are at the unit elastic point, and the unit elastic point happens halfway. So it's 150 plus 33, so 183. And then the only piece that I've added that is the assertion that I didn't give you a logic for is the straight line part. I did not explain to you why it's a straight line. I explained to you why this is zero, unit elastic. I explained to you why this is the way it is. So those two pieces I explained. I never explained why this is a straight line here. It didn't have to be a straight line. It could have been squiggly line, convex line, concave line. Could be all kinds of stuff, but I'm asserting strongly that it's a straight line. The reason this is straight line is we applied a little bit of calculus and we figured it out. Okay, so that's it. I'm not going to use class time to talk about the formula, but it's pretty straightforward. If the demand curve is P equals A minus BQ, then the total revenue is A minus P equals, total revenue is AQ minus BQ square, and then you differentiate it with respect to Q, and you find it out to be a straight line with double the slope. Erase all of that if you haven't taken calculus, doesn't matter. Okay, so, but if you have taken calculus, maybe that made sense to you. Outside of class time, right after class, I'm happy to talk about it. So remember when we were doing indifference curves, I would give you the MRS for Cobb-Douglas. You remember that, right? The A divided by B multiplied by Y divided by X. And I said, hey, where did that come from? Trust me, you can apply calculus and figure that out. You don't need to know calculus, but that's how we found it. Similar thing can be done here. We can use elementary calculus to show that it will be a straight line. Okay, so this will remain an assertion in this class as far as your understanding goes, but you should remember the assertion came from applying calculus. And if you want to know how it was outside of class time, we can talk about this. So I'm not going to ask you why this is a straight line. I'm going to assume you recognize that it is a straight line because why? Forrest said this is how it happens, and calculus tells us that's the case. All right, so there's not going to be any more intuition there. It's just going to be an assertion. It's a principles course. We are not going to do calculus here, but we're going to use that particular result from calculus here. So it's a straight line. That's it. So now that we have our marginal revenue, we basically know how to solve the monopoly problem. So let's go ahead and solve the monopolist problem. It's going to be fun. We are trying to solve the problem of, for the 25th time, writing it down, this is 100, this is 50, and this is your marginal cost of 4. All right, so now we have what we need. We have our marginal benefit, or marginal revenue. Marginal revenue will look like this. It will start here. It will go through 50. Keep going downwards. Now this is simply cost-benefit analysis. Marginal benefit, in this case, marginal revenue, starts above marginal cost and intersects only once. Oh boy, we love marginal analysis when we can apply it. And we can apply it. They intersected only once. This is the quantity that the monopolist should be producing, not 50, where they intersected, right under that. So they should produce here, and the price they should charge, and make sure you don't make a mistake, when they sell this quantity, the price they charge comes from the demand curve. So that's the actual price they're going to charge. And so we figured out where the monopoly price is. and the monopoly quantities. Alea.
Yeah. Why is the MR 50? I'm just confused about. Is that the point that it's intersecting?
I have no idea what you're talking about.
Okay.
I've
Thank
seen you do
you.
this in class every now and then. You just ask a question that makes absolutely no sense. I wrote 25 and you're saying 50. Yes, it's 25. You're absolutely right.
Okay. Thank you.
Yeah. So did that make sense? So like basically you have, if I started with the marginal revenue curve and I called it the marginal benefit, you would jump on that answer pretty fast. Marginal benefit, marginal cost intersect once. That's the quantity you produce. Done. The only little piece that's additional here is, now that you know the quantity, you look up to the demand curve and then you figure out what the price is. So let's mathematically solve this problem. Mathematically, I would say my marginal revenue curve equation is marginal revenue equals, well, 100 is the intercept minus what is the slope for Q. So marginal revenue is always in terms of Q. Every time you sell one extra unit, what's the extra money you bring in? It's a function of Q. So marginal revenue is that. And what is my marginal cost? Oh, I know that. Marginal cost is 4. Okay. How do you solve for the quantity you should produce? You set your marginal cost equal to your marginal benefit, MC equal MB. So you set them equal to each other. And once you set them equal to each other, I think you get your Q to be 96 divided by 424, I believe. So this number should be 24. And once you know that number is 24, you can also look up in your demand curve. Your demand curve was P equals 100 minus 2Q. So you put Q equals 24 in there, you get 48, so that number becomes 52. Cool. Got it. I know that we arrived at the result after lots of little detours here and there, lots of discussion, but at the end of the day, solving the monopoly problem is actually not very difficult. 2 steps. Figure out marginal cost, marginal revenue. Second step, well, the intersection gives you the Q, and looking on the demand curve, you know the price. Done. All right, cool. Questions? All right, so in this particular picture, now let us look at what the consumer surplus is, what the producer surplus is. So here, the consumer surplus will be this region. The consumers pay this price, and they get to buy this amount, but they were willing to pay all the way up there. So this is consumer surplus. Producer surplus is going to be, well, they were marginal cost was here, but they got to charge the price up there, and the monopoly sold all the way up to here. So this is producer surplus. But if you think from the society's point of view, society would say, you know what? For us, we don't care about marginal revenue. We are a freaking society. Why do we care about marginal revenue? Every time something is produced, this is the marginal benefit. This is the society's marginal benefit. Society. Because every time something is produced, somebody eats it, the consumer eats it, that's the marginal benefit we get. So society would say, produce all the way here. This is the societal optimal, or societal efficient point. And when they do that, everything becomes consumer surplus all the way up to here. Make sure you understood that. So society would say, charge this price, produce all the way here. Producer surplus will be 0 because marginal cost is 4. They're selling it for 0. But all of this big triangle is going to become consumer surplus. And that is a way bigger economic surplus than what the monopolist was going for. Kind of very similar to what we already saw in the picture before. And you're going to end up with the story that when the monopolist operates, from the society's point of view, this is the deadweight loss. The society is not able to go for that. So monopolists in that sense are also not efficient. Economics as a discipline is not a big fan of monopolies or big corporations or market power. We are pretty much strongly opposed to that precisely because of these reasons. Price gouging, meaning they raise the price a lot more. There's less being sold in the market, not also good for economic surplus. So you are not going to find any serious economist who is going to defend monopolies. Okay. Let me qualify what I just said. There are some monopolies that even economists will say is a good thing to have. Can you imagine where economists would say, you know what, leave that monopoly alone. It's a good thing that we have that monopoly. Why? We already made a bunch of cases. That's why monopolies, society's point of view, no good. Deadweight loss, price gouging, we get that. Why would some people say, no. There is place for monopolies sometimes. Any ideas? I see somebody wrote something in the chat. Yes, Ian, go for it.
Maybe like military producers who produce like, I don't know, fighter jets for the US government, and then like they're the only ones who know how to produce it, and they don't want to spread the information around, I guess.
Okay. So for strategic good, something that is very strategic with sensitive information, you may not want a lot of people having access to it. Yeah, that could be it. That could be it. I think I got an answer in the chat window. Maybe organ donation, but I'm not sure. Yeah. Organ donation, do we really want monopoly? Because if you want monopoly, then somebody could kind of go and say, I have an organ that you need. You have to give my family $3 million. Do we really want that? So maybe not. But strategic reasons, yeah, that could be one. Companies that produce a lot of carbon dioxide, so it would reduce the quantity emitted. Companies that produce a lot of carbon dioxide, so it would reduce the quantity. Well, it depends. So the story is, if there's lots of firms and they're all producing a lot of carbon dioxide, and we're like, well, we rather just one firm produce it and kind of cause carbon dioxide and let's get rid of the rest. Well, that's not really monopoly. You're just reducing the amount being produced. So you could tax the system and reduce the amount being produced. But if you said monopoly, then there would be one firm that is producing everything, and it would become a much bigger firm. And they could probably get away with a lot of pollution because people don't have an option. So maybe not the best case there. Okay, I will give you the answer. Here's one answer. There might be others. The case for a natural monopoly. So let me tell you what a natural monopoly is. Well, it sounds very natural. So a natural monopoly is the scenario where the more you produce, the average total cost of producing the thing goes down. So look at this cost curve. 1 million plus 0.01 Q. You may be looking at this and say, okay, here we go, stupid economists making up made up examples again. Wouldn't be the first time. You know what? Screw you. I'm going to put another zero here. I just made that 10 million. Where could this even be true? Let's put another zero, 100 million. Where the hell could that really be true? What kind of firm has a total cost curve that looks like that? Your cell phone companies. You have to launch a satellite and send it up into the air, potentially, or what Elon Musk is trying to do with internet right now. Send a satellite up there. Once they've launched that satellite and it goes up there, which costs millions and millions of dollars, now every phone call costs even 1 cent or less, 0.001 cent maybe. Oftentimes there are railroad. The first time you're putting down rails, that's expensive as hell. Once you've put down the rails, once you've built that train, each ride is actually not that expensive. It's really not that expensive. Making CDs, trying to make, laser computer, blah, 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 that will make CDs, something that your generation is completely forgetting exists. It is expensive to set up all those lasers and getting all the CD production machinery up. But once you do that, producing a CD is actually less than a cent. It's super cheap. So oftentimes there are lots of things where the fixed cost is really high. But once you kind of go beyond that hump of that massive fixed cost, the cost of actually producing more units is very low. The marginal cost is very low. These are the scenarios where we call them natural monopoly, or in general, where if you were to draw quantity versus cost, your average total cost keeps falling forever. So notice in this particular problem, if you were to make just, or in this particular example, if you were to make just one phone call, the cost of that call would be $100 million and 1 cent. But the very moment you try to make 2 phone calls, the cost is halved. Because that $100 million and 0.01, 0.02 cent is now divided by 2. So now you have $50 million and 1 cent. If you then try to make 3 phone calls, it just becomes $33 million per phone call. Now, if you start making 1 million phone calls, all of a sudden the price of a phone call has dropped down to pretty much, $100. If you make 1 billion phone calls, the price of the phone call has gone down to less than 10 cents. So the more you're producing, the average price is going down. So the way to think about this is, in this particular problem, average total cost is equal to this thing divided by Q. So you get 100 million divided by Q plus 0.01, because when you divide this by Q, they will cancel out. And if you notice, this thing is definitely going down, 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 down as Q goes up, 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 up. And you don't want to keep sending satellites. So imagine we wanted to make 1 million phone calls, and you're like, oh, you guys want to make 1 million phone calls? I got a great idea. Perfect competition, guys. Each and every one of you should send 1 satellite up there. Send 1 million satellites up there. Isn't that a great idea? We like perfect competition. Horrendous idea. Every time you send a satellite up, it's taking $100 million. Why would you ever in your right mind do that? You wouldn't. That's a market you would look at and you say, you know what? This is the market for natural monopoly. This is the one where the government gives one firm the right, like, no, you're the one, you send satellites. Or 2 of you, you 2 send satellites. The rest of you, sorry, you don't. You guys all figure out a deal. And then the government regulates that industry. Regulates, says, okay, I have given you the monopoly rights. I'm also going to keep my eyes on you so you cannot price gouge, and I will heavily regulate you. US Postal Service. I'm giving you the monopoly right. For the most part, there's FedEx and a few other, but mostly UPS, you have the right to move postal services around. But you know what? You're not going to go free reign charging any price you want. We will also regulate you. The government will own you. Our government will own parts of you. So you don't get away with it. But we rather one firm take care of it as opposed to 5 different or 200 million different firms.